So I was out on a foundry floor last week, right? And this guy is standing next to a grinding station, holding this dead cordless grinder like it personally insulted him. He tells me it's the third electric motor they've burned through this month. Third one. Because the fine iron dust just gets sucked right into those vents and boom. Short circuit, total meltdown.
Three in a single month? That that is just a massive waste of money. But wait, aren't the newer electric ones supposed to be sealed or at least have some kind of dust protection?
They claim they do, Lisa, but the reality of a high production shop floor is just it's brutal. You've got extreme heat, abrasive dust, moisture. I mean, pneumatic tools, they don't care about any of that. They can run all day in temperatures from 45 degrees all the way up to 180 degrees Fahrenheit. Try doing that with a lithium-ion battery without it literally shutting down to save itself.
180 degrees? Wow, that is seriously hostile. And I guess with air tools, there's no actual motor inside to burn out, right? It's just air pressure spinning the rotor.
Exactly, it's just a simple air motor. No windings to melt, no delicate circuit boards to fry. If you plug the vents, it just keeps pushing through. Or worst case scenario, if the tool binds up completely, say a big drill bit grabs a piece of structural steel, an electric tool is going to draw massive amperage, get hot, and try to wrench your wrist off with that violent kickback.
Oof, yeah, the kickback. I've felt that. It can really twist your arm if you aren't ready for it.
Right. But with a pneumatic tool, if it binds, it just stalls. The air just stops moving. There's no buildup of electricity, no violent kickback, no damage to the internal parts. You just back the tool out and you're good to go. It's built-in stall-out protection.
So it's intrinsically safer. And I'm thinking about wet environments too. If you're doing, say, wet sanding or working around conductive metal structures, the absolute last thing you want is a corded electric tool or even a high voltage battery near water.
Oh, absolutely. Zero electrical shock hazard. None. And no sparks either, which is why you see them everywhere in paint booths, chemical plants, oil rigs, anywhere where a single tiny spark could, blow the whole place sky high.
Right. Explosive vapors. That makes complete sense. But what about the people actually holding these things for 8 hours a shift? Because I've picked up some of those heavy-duty cordless impact wrenches, and after 10 minutes, my wrists are already feeling it.
They are massive, Lisa. You're lifting a heavy electric motor in a huge, clunky battery pack. Air tools don't have either of those. They're significantly lighter, smaller, and way more maneuverable. So the operator isn't fighting the weight of the tool all day, which means less fatigue, fewer repetitive strain injuries, and honestly, just a lot less sick leave on the books.
Okay, but let's play devil's advocate here, because if you go cordless, you just pop a battery in and go. No hoses to drag around, no big compressor system to buy. Isn't managing a bunch of hoses its own kind of a nightmare on a busy floor?
It's a common argument, but let's look at the actual infrastructure of a battery fleet. Say you have 50 workers. To keep them running continuously, you need a revolving inventory of expensive lithium-ion batteries. You need at least 2 per tool, 1 in use, 1 on the charger. And those batteries cost what, $159 each?
$159 for just one battery? Geez, that adds up fast. Especially when they start degrading after a few hundred cycles and don't even hold a full shift's charge anymore.
Exactly. You get this staggered degradation where worker A gets 4 hours of runtime, worker B gets 2, and suddenly people are wandering around hunting for a fresh battery, stopping production mid-task. With a central air system, if you already have the pipe drops, you just thread a drop to the workstation, click in a quick connect coupler, and boom. You have infinite runtime at 100% torque from the start of the shift to the end.
And you're powering all of this off of a central compressor room, right? Like those big rotary screw air compressors we always talk about for heavy industrial setups.
Yes, exactly. A reliable rotary screw air compressor is the heart of the whole shop. It delivers that steady, continuous volume of air you need, so the tools never lose pressure. And the adjustability is incredible. You don't have to cycle through low, medium, high digital settings. You just adjust the inlet pressure or feather the trigger, and you can dial in the exact speed or torque you need on the fly.
So you get that soft touch for delicate work, but you can still crank it up for aggressive grinding with the exact same tool. That is actually incredibly versatile.
It is. And when an air tool finally does need maintenance, which is usually after thousands of hours, not the 100 hours or so you get with electric, you don't throw it in the trash. Any basic technician can rebuild a pneumatic impact wrench in 15 minutes using a simple $20 seal kit. Try doing that with a burned-out brushless electric motor.
A $20 kit versus buying a whole new electric tool because the parts are discontinued. Yeah, when you look at the lifespan spanning decades instead of years, the ROI on pneumatics is just a landslide. All right, I'm sold. Let's head down to the shop floor and check out those quick connects.